We'll begin this section by talking about the tic and toc functions within MATLAB. And these are used for timing, often used for timing sections of our code. So there's separately the tic function, which is going to start a timer within MATLAB. Internal, we're not able to see what it's counting, but we can check it by using the toc command. So again, tic is going to start a timer, so I'll enter that in my command window. So inside, as soon as I pushed enter, it started a timer at 0. And I can check how much time has elapsed since I entered tic by putting in the toc command. In this case, 8.5 seconds since I entered tic. If I enter toc again, it's measuring from the last time I entered tic. So if I keep entering toc, it's not since the last time I checked it, it's since the last time I hit tic. So again, we'll check it with toc one more time, and now if I enter tic, I reset that timer. And now when I click on toc, it is reset because it's the time elapsed since the last time I clicked on tic. Now this is useful for timing sections of your code or your entire code from top to bottom. As we saw in kind of the previous example problems, the code ran very quickly and we didn't really have to worry about how long it was taking for a section or the entire thing to run. But as we get more complicated pieces of code, we might be concerned that sections take longer than we want them to. So there might be a more optimal way to code a section, and the tic and the toc feature, if we can see how long a section takes us to run, could tell us where we should try to optimize our coding. So here we're going to look at how long it takes for different functions to run in MATLAB. So I'm going to clear everything and then start a timer using tic. And what I want to do is see how long does it take to find the eigenvalues of a 10 by 10 matrix. So I'll talk about what this is doing in a second here. If you're not familiar with what eigenvalues are, they're from linear algebra. We're not going to use them really that much in this course, but it's a very time-consuming process by hand to find eigenvalues of a function. And also for MATLAB to do it, we're going to see that it can take longer and longer and longer the more eigenvalues we have to find. We'll discuss this rand feature in a couple weeks when we talk about random numbers, but briefly what this is doing, if I run just this rand 10, it creates a 10 by 10 matrix of random numbers between 0 and 1. So we see the output is this 10 by 10 matrix, everything is between 0 and 1. And every time I rerun this section, I keep clicking F9 and rerunning rand 10, it's making a different 10 by 10 matrix with every entry between 0 and 1. So what I'm doing here is I'm just finding the eigenvalues of this 10 by 10 matrix, and there'll be 10 eigenvalues. Here there's a mixture of real and complex ones. Every time I rerun it, since I'm finding the eigenvalues of a different random matrix, that's going to change the eigenvalues. So what I want to look at here is how long does it take for this section of code to run. So really what I'm testing is how long between the tic and the toc does it take to run. So it's only going to see how long does the eigenvalue of a 10 by 10 matrix take. So I'm going to run this. Let me suppress that. Alright, so we see it found the 10 eigenvalues and it took 0.001333 seconds, so a very minimal amount of time. If I keep rerunning this, it does take slightly different every time I run it. Again, pushing Control Enter continuously, but it's all in the realm of 0.001 seconds, more or less. But what we have happen is, if I now take the eigenvalues of a 50 by 50 matrix, so this rand 50, again, what is it doing? It's making a 50 by 50 matrix of random elements between 0 and 1. So if I now run this section of code here over and over and over again, it's finding 50 eigenvalues. And what we're seeing is we keep running it, and it takes certainly longer than it did the first time when we only had a 10 by 10. It takes about 0.002 to 0.004. And if I make this bigger, find the eigenvalues of a 200 by 200 matrix, and run this, it now takes appreciably longer. So rewriting this over and over again, somewhere in the neighborhood of 0.05. And if we really make it large, 500 by 500, we see that it takes in the neighborhood of 0.4 seconds for this to run. So the bigger the operation we have to do, the longer MATLAB takes for it to run. Now, just some caveats of using Tic and Toc. It usually gives us a rough estimate of how long a section of code is going to take. But you see, one thing is every time I run it, it takes a little bit different amount of time for it to complete the operation. So oftentimes, if we really want to test how long something takes, we have to run it a couple of times, and then we can come up with an average value. And something else to keep in mind here when we're using Tic and Toc is that it's counting how much time has elapsed on the computer since the tick was initiated. So if you're running other processes at the same time, like you're using Word or playing music, that can bog down the processor a little bit and actually slow down your code. So Tic and Toc have to really be relative calculations. So if all the other processes running on your computer are the same between when you run one section of code and another, then it's a fair comparison. But for example, if I ran this on two different computers, if I ran this on a tablet PC and I ran this on a desktop, the same bit of code is probably going to run much faster on my speedy desktop than it's going to run on my tablet. So again, when we're comparing the elapsed time, we really want to make sure that we're comparing it kind of apples to apples. So the same processor, the same tasks from one time to the next.